Hello everyone, welcome to class 5 of CM1. I'm Pratap from Smears Education Solutions. We'll discuss today more problems on convertible rates because they are so important in annuities, and annuities in turn help you to study in a proper way the rest of the chapters. So we'll practice more questions in today's class in the next 2 to 3 classes on interest rates. Let's get started. So this is the first question. Calculate the nominal rate of interest per annum convertible quarterly equivalent to an effective rate of interest given, that is 0.5% per month. So what is given we have to write. That is very important. And also what is required. Both things you need to write. So an effective rate of interest of 0.5% per month. Effective rate of interest 0.5% per month. So we are talking about 1 month interest rate. It's not a convertible one. There is no word convertible or nominal here. So 0.5% per month, that's a monthly interest rate. That's a monthly effective interest rate. So I-12 by 12 is given 0.5%. 0.5% is actually 0.5%. And when we talk about 0.5%, that if you convert to a number, this will be 0.005. This is 0.5%. Using this value, you can find this one. Nominal rate of interest per annum convertible quarterly. So what is that you need to find here? Convertible quarterly. That means you need I4, convertible quarterly, I4. It's not the effective one. It's not converted. That's why it's IP. So you need to find I4 from I-12 by 12. That is one. Then the second one is a nominal rate of interest of 6% per annum convertible every 2 years. This is a convertible interest rate. So given I-half, this is convertible every 2 years. 6%, 0.06. This is given. So there are two questions. The first one is from I-12 by 12, we have to find I4. And the second one is from I-half, you have to find I4. For everything, we'll use this formula. 1 plus IP upon P power P. If you are not sure about the symbol, the actual symbol, you can go back and you can see my earlier videos, 1, 2, 3. This is the only formula we'll use to solve this problem. This is the only formula. Though P will be different. Now let's do part 1. Here, I-12 by 12 given, you need to find I4. So I will write I4 to the left because I want it. I will start with this. And then instead of finding I can find I from I can find this one. But I would like to write directly the formula. This is the formula. 1 plus I4 by 4 power 4 is equal to 1 plus I, and that is in turn equal to 1 plus I12 power I12 by 12 power 12. Now we need to find I4 here. You take out the middle part, that is not required anymore. 1 plus I4 by 4. This power 4 you take that side. If you take power 4 that side, it will be 1 plus I12 divided by 12. 12 by 4, that will be 3. And then put I12.005. 1 plus 0.005 divided by 12 power 3. Then take 1 that side, use a calculator, and then find I4 by 4. And I4 by 4 is not the answer. So you have to find finally I4. You multiply 4 once again, then you will get the answer. So you check that, you will get 0.06031. That is 6.031%. This you should get. Number 2, nominal rate of interest of 6% per annum convertible every 2 years. I've already written the symbol, and the left hand side will not change. Here in part 2, we'll change the right hand side. We'll write 1 plus I4 divided by 4 power 4 is equal to 1 plus I half divided by half power half. That implies P, I've taken half here. It could be a fraction. This is the actual symbol. So 1 here I have given 0.06, you put here. Then you solve this one and find the number 2 says 900 accumulates to 925, accumulates to 925 in 4 months now. So you have to write in terms of years. This is 0, this is 4, and you write 900 here, and then 925. This is what given. Calculate the following. The nominal rate of interest per annum convertible half yearly. You need to find this one. I2. Here. The nominal rate of discount per annum convertible quarterly. D4. The simple rate of interest per annum. I simple here. Simple I. These are the 3 you need to find. So let me write here this way. 900 accumulates to 925, and we need to find I2. If I write this way, 900, this is one equation you can write, 1 plus I, it's 4 months. So I can write 4 by 12. You can solve this equation, find I. This is one way you can write. Otherwise, you can write, if you take here half yearly given, it's monthly. So you can take monthly also. But we don't need that. So this formula, if you write, it's better. Because this is 4 months, you can write 4 by 12. This is also true. If you take monthly, there are 4 months. But how it's going to help you? That's what. Sorry, I12. I12 divided by 12 power 12, that is equal to 925. If you solve it and find I12, how it's going to help you? If they find I12, you can take this, 4 months here. So what I've done is, I have made 4 intervals. and power 4 I've written. In that case, you can find I12 by 12. You find I2 from this, you find D4 from this, you find I from this. But not useful. Let me write simple here. So it's not useful. Will not write it. This I is the compound I. So here you need to use this to find whatever you want. This is what given for you. Because it's not a complete year, you got a fraction here, 4 by 12. Doesn't matter, whatever it is. So in part 1, you need to find convertible half yearly, I2. So directly we can turn this equation in terms of I2. That is one method. Or you solve this one, find I, from I you find I2. But I would prefer this one, 1 plus I2 by 2 power 2. Directly, why not I can write here power 2, because if you get power, another power, you need to multiply. That's all. You solve it and you get the, 2 into 4 by 12, that's 1 by 3, 2 by 3. You take that side, 900. Then 2 by 3 power, you make it, subtract 1, multiply by 2, you get I2. That's all. It's easy. And in the second one, the nominal rate of discount per annum convertible quarterly. Nominal rate of discount per annum. So you need to find D4. So you have to write corresponding D4 formula. So one way is, again you can solve this one. Let me write this one as well. Again you can solve this one, find I, from I you find D. There is a link between I and D. From D you can find D4. But that will be quite a long process. We would like to answer in one line. So if you want to do that, you directly write something where D4 will come. So 1 plus I is 1 minus D power minus 1. 1 upon 1 minus D. 1 minus D is V. V is 1 upon 1 plus I. So remember, there is a link between these two. Power minus 1. You can write this way. There are several ways. You must feel comfortable in some way. If you are not comfortable, then you can go back and you can check that things are fine. Now you write here 1 minus D power minus 4 upon 12. That will be equal to 925. Then 1 minus, again, 1 minus D, there is a formula, we'll use that. 1 minus D4, because we want D4 here. 1 minus D4 by 4 power 4. Power minus 4 by 12. 925. That implies this 4 and 4 you have to multiply, right? So here we have power 4 by 12. Again we got 4 here, 16 by 12, whatever it is, minus is also there. So 1 minus D4 by 4 you need to write here is equal to 925 divided by 900. This power minus 16 by 12, here minus 12 by 16. You can cut it also, use a calculator, find its value, then subtract from 1, multiply by 4, you will get D4, that's all. And the last one is simple rate of interest I. Okay. So for simple rate of interest, we will not use this equation at all. We can do it directly using simple rate of interest. We can do part 3 here. Let's make it simple. If it's a simple rate of interest, this I have taken compound. Why to go there? Directly we can write this way: 1 plus I power n, 1 plus ni it will become in case of simple interest rate. N is 4 by 12. So you write 4 by 12 here. 4 divided by 12, I, that will be equal to 925. Solve it and find I. So these are the three parts of this question. I will write the answer also so that you will be able to check. It should be equal to 8.33% approximately. And this one, 8.14%. Let's go to the next question. Calculate the time in years for an investment to double. Suppose you keep 5,000, it should grow to 10,000. That way, your money will double. Double in how many years? Roughly you think. If you want to get 1 lakh, you deposit now 50,000 and it should be 1 lakh in how many years? That will depend on the interest rate. Here, effective rate of interest. Remember, effective rate of interest means compound. So you have to use log in these cases. Double means if you start with x in n years, it's a compound interest rate problem. It should double, that's all. X will grow to 2x in number of years. That number you have to find. 0 to n, suppose n years, you deposit x, get 2x. You see how many years it will take. If you take n years, the equation will be like this. Then you cancel x from both the sides. You take log ln, I can write 1 plus n, 1 plus I power 1 plus I power n. This is ln2. You can use a calculator. Then n ln 1 plus I 1.10. Then to find n, you divide ln2 divided by ln 1.10. And if you know that bank is giving you 10% per annum interest, it's quite high though. It doesn't matter. It's a question. It will take around 7 years. 7.272 years. This much time it will take to get double amount. Now, instead of this, here nominal discount rate is 10% annum, convertible monthly. That means D12 is given 0.10. So in this case, instead of putting there, we'll change it to D12. This equation will change it to D12 and we'll put there. Or from D12, you find D, from D you find I, and you put here. But again, we'll not do that. This equation only will change it to 1 minus D minus 1 power n, that will be 2x. Then in 1 minus D, you write 1 minus D12 by 12 power 12. Power 12 minus 1, it will be minus power 12. N also I can write here. 2x. You can cancel x from both the sides. Then you put 10% here. 1 minus 0.10 divided by 12 power minus 12n is equal to 2. You take log both the sides ln. You can use a calculator. You will get minus 12n value. Then if you divide it by minus 12, you will get the answer. 6.902 years. So it takes less years here. You compare D12 and I. Which one is greater? It will depend on that. D12 10% is more or I 10% more? Think for some time. Can you compare I and D12? If you are thinking D12 we can compare with I, that's wrong. Because this is very important, you should know. I is not far away from I2. I2 is not far away from I4. I4 is not far away from I12. ID also they are not far away. Then D2, then D4, then D12. So they are not far away. I 10%, D12 10%, they are approximately equal. You find, if you remember, for I 10%, I 365 was 9.53 something. So I 12 will be around 10%. Okay. So 9 point something. Because this is not monthly interest rate. This is convertible monthly. You have to divide it by 12. Then you get monthly. Even this is also not a month discount rate. This is discount rate convertible monthly. You have to divide it by 12. Before dividing, it should be more than 9. This should be more than 9. Now, if you remember, I 10%, I'm not talking about I12, I'm talking about D12, I12. If I take, if I is 10%, D is 9.10%, and all the values will be close to 9.10%. All these values will be close to 10%. Then when you divide by 12 here, you get monthly interest rate. You divide by 4 here, you get quarter interest rate. You divide by 2 here, you get half year interest rate. And which one is greater? I is greater or I12 is greater? This inequality you need to know. I is greater than all these interest rates. Why I is greater than I2? That logically you need to decide. Why I is greater than I2? You have to think on this and where it's going. I'll discuss a bit of this later in the next class. This is a problem solving class. Calculate the nominal rate of discount per annum convertible monthly, which is equivalent to an effective rate of interest 1% per quarter. This is 1% effective rate. 1% effective rate. That means I4 by 4 is given here. Not I4. There is no convertible word. There is no nominal word. So this is 1%, 0.01. A force of interest. Okay, this one I will teach. Okay, this is not over now. We know only I, IP, DP. A nominal rate of discount of 4% per annum convertible every 3 months. Nominal rate of discount of 4% per annum convertible every 3 months. Mark the difference. Very, very important. Convertible every 3 months means quarterly. 4 months means that's different. 4% convertible there. So it's not converted. 4%. So convertible every quarter, right? Quarterly. So D4 is 4%. Discount rate. We'll do it later. The nominal rate of discount per annum convertible monthly. That means D12 you need to find. Now you need to establish connection. That's all. Connection between this and this, connection between this and this. It doesn't matter whether I4 is given, I4 by 4 is given. Ultimately, you need to find D12. Where you need to put, in the numerator or in the whole, that's what matters. So what you need to do is, you start with the first one. You need D12, so I'll write D12 to the left hand side. 1 minus D12 by 12, I need to write. Power 12, that is 1 minus D. 1 minus D also I have to change it to 1 minus 1 plus I power minus 1. That is V. V is 1 upon 1 plus I. And 1 plus I is 1 plus I4 by 4 power 4. Power 4 power minus 1. That is power minus 4. So now you put this one here in the whole I4 by 4. Here you put 0.01, not in the numerator, because effective given per quarter 0.01. So 1.01 power minus 4 is what? This expression. So then take 12 this side. You get 1 minus d12 by 12. From that, you can find d12 by 12. From d12 by 12, you can find d12, because we need d12, not d12 by 12. This is very important. 3.9735%. 3.9735%. This is what you will get. Now, how about this one, part 3? Part 3, we can do because now we have to connect with D4, and again we need to find D12, and D4 we need to connect. That's all. There is no I here, no I seen. D4, D12 you need to find from D4. So you need to find D4. So I'll write 1 by D4 by 4 power 4. That is 1 minus D. I'll not go to I now like this, because D12 is what you need. Okay. Here I need to, okay. Anyway, I've written, I will not change it. 1 minus D12 by 12, I should have written to the left, no problem. What you need is D4 you put here, and you take out this middle part, you put D4 value, you solve this equation, find D12, that's all. It's easy. These are so important. I can't say it now. You'll be able to know later. So practice a lot. We'll have some more practice sections coming up. And don't lose these things. If you develop properly, then later it will be very, very helpful to you. This much for today's class. If you enjoyed, you understood, please like and share and subscribe to our channel as well to keep up with further content. Thank you.